Hello, damas and caballeros. Here is my second video on non-linear kinetics. We'll learn some calculation when you have only one plasma data. We have learned calculation when you have multiple plasma data. Then now we'll learn how to calculate Vmax and Km. You have one plasma data. And CSS and TSS, steady state concentration and time to reach steady state concentration. Time to reach steady state concentration. We'll calculate how to calculate time to reach steady state concentration, and we'll see how those CSS and TSS are related. I'll also learn about Km, Vmax, how they affect my phenytoin dosing, review competitive and non-competitive inhibition. I have collected a video for you to review, so if you have forgotten competitive, non-competitive inhibition, what you have learned in biochemistry. First, if you have one plasma data, we know that we have multiple plasma data. We do R versus R by CSS, but you have only one plasma data. In that case, you can use Km. You can substitute. You can use either this nomogram like this. These are old style, but these things are now available in computer. You can put Km, Vmax. You can calculate dosing rate. So you can also you can use population average value, which is Km. For Km is 4 milligram per liter for phenytoin, along with the dosing rate and plasma concentration. You can use any one of the following equation to calculate Vmax and Km. I have already discussed this equation in assignment. I think it is part 1 assignment, so I'm not going to go over this material again. The same equation to calculate time to reach 90% of the steady state. In assignment video 1, I have explained this concept, so also I will explain in this calculation in the class, so let's skip this. Now some of the concept we have to discuss, because in assignment there are some concept question, and I will ask some concept questions. First, how CSS is steady state constant, TSS is time to reach steady state constant, are related to the dose in case of phenytoin. As you can see, with this is dosing rate is increasing, CSS increases with the dosing rate, and time to reach also increases steady state with the dosing rate. And is as you can see, the therapeutic dose when it is given 400 milligram per day, CSS of 16 milligram can achieve after about 16 days. And so this is a relationship that with the dosing rate, CSS increases and time to reach CSS also increases. This is the relation. This is in case of phenytoin, because phenytoin is one of the drug, as I have mentioned. It is has non-linear pharmacokinetics, so you have to remember this. So now how the different enzyme induction or enzyme inhibition affect Vmax and Km of phenytoin especially. First, disease, age, drug may change the Vmax and Km. So anything, disease, age. One of the example is carbamazepine and phenobarbital increases the Vmax by enzyme induction. That means Vmax increases, that means velocity of metabolism is increasing. So as you can imagine, metabolism increasing, that means more drug is undergoing degradation. So dosing rate of phenytoin in this case should be increased, because this two drug will decrease concentration by inducing enzyme, by producing more enzyme. So it will decrease phenytoin concentrations. For this reason you have to increase the dose of phenytoin. Another scenario, when for example you have stabilized, you have a patient who is taking phenytoin and these two drugs, phenobarbital and carbamazepine, you have stabilized those drugs. So now when you discontinue this drug, what do you have to do? So adjust. Because of this enzyme induction, you have increased the dose, but if you discontinue, what you have to reduce the dose. So for this reason, always we have to be careful, because these two drugs, phenobarbital and carbamazepine, increases produces enzyme induction, increases the metabolism of Vmax of phenytoin. So another dish like hepatic cirrhosis decreases Vmax. So when Vmax decreases, that means plasma concentration is going to increase. Drugs like cimetidine, chloramphenicol increase Km by enzyme inhibition. When it increases the Km, that increases plasma concentration. So in this case, when plasma concentration, you have to also adjust. So these are concept question, study hard. I would ask question from here. So relative effect of Vmax and Km. In these two slides, I will explain that which parameter have more pronounced or more powerful influence on the dose, on CSS. First is Vmax. Change in Vmax will impact more. Change in Vmax will have more impact on CSS. So here you can see that in normal circumstances, an increase in the dosing rate will increase CSS non-linearly. For example, when twofold increase in Km will increase CSS by twofold. It does not matter what the dose is. But when a twofold increase in Vmax will decrease the CSS by more than twofold. So always you have to remember, Vmax increases, CSS goes down. It makes sense. Vmax, that means rate of degradation. When rate of degradation is, CSS will go down. But in many cases, if you increase VA, if you take like Vmax become 2 times increase, CSS is going to decrease more than 2 times. More CSS. So you expect for Vmax, twofold increase in Vmax will be equivalent to twofold increase in CSS, decrease in CSS. But this does not happen. Even it is CSS goes down further. Here in this curve you'll see a change in, you see here we have plot CSS and there is a plot of dosing rate, and it is showing that change in case of normal, this is the normal one, and then in case of inhibition, came changes, little change in K, a change in again CSS and metabolic rate, a change in Km. That means here this curve is showing change in Km has not much dramatic effect on the CSS, but Vmax, you see here, You see how the change in Vmax? This is change in Vmax. When Vmax changes, this is normal. In case of enzyme induction, this is CSS goes down dramatically. Here in case of my normal induction, this is normal, and rate of metabolism increases tremendously. That means Vmax has more dramatic effect on CSS than Kn. That means change in Vmax has more dramatic effect than change in Kn. Now I want you to review this, that inhibition, what happens in case of competitive and non-competitive inhibition. In case of in biochemistry, I guess Dr. Stoll or somebody has taught you that in case of here it is, there is no inhibitor, drug and enzyme binding. This one is showing no inhibitor. In case of competitive inhibition, Vmax does not change. So Vmax remain unchanged, but Km decreases. So in this case, Vmax do not change. Km decrease. Km decrease means, you know, the Km is a dissociation constant. Decrease means it has more affinity. So in the same assignment, if you go back to the note, let's see. Here I have talked about somewhere Km. Let's see. Km is a dissociation constant. Km is a dissociation constant. I have talked about it. Km is a dissociation constant which decreases as the affinity of the enzyme increases. So when Km decrease, affinity will increase. When Km increase, affinity will decrease. So here, if you read this carefully, there will be some question based on the competitive inhibition and non-competitive inhibition. So I want you to read this. That means when in case of non-competitive inhibition, yes, Vmax does not change, Km is increased. Vmax, this one, Vmax remain unchanged, but in this case Km does not change, but Vmax decreases proportionally to the inhibitor concentration. So no change in Vmax, Km decreases. Here non-competitive, again that's non-competitive, no change in Vmax, Km goes up. Here Km in case of non-competitive does not change, but Vmax decreases. Vmax goes down. And here I have a video. After I go over the question, possible question, I'll open that video for you. So here I have also listed what happens. Competitive inhibitors, Km increases, In case of Km increases, and in case of displacement Km decreases, what happened to the plasma concentration of drug? There is a summary. But if you watch that video, this is the video link. I'll play this video in a minute. Here now you have to answer some of the question. How CSS and TSS changes with the increase in phenytoin dose. So with the increase in phenytoin dose, CSS here, dose increase, CSS increases, TSS also increases. If you go back to the note, you'll see how enzyme induction and inhibition influence the plasma concentration of phenytoin. You have to remember there's some drugs I talked about, I think is carbamazepine and phenobarbital. If enzyme induction, that means it produces enzyme. For example, this phenobarbital, I guess, phenobarbital, it increases enzyme. So that means when enzyme increases, Vmax is going to increase. Vmax increase, that means it's going to break more drug. So dose, if you have to adjust the dose, you have to increase the dose. Okay, because when Vmax increases, what is going to happen to CSS? CSS will go down. So to adjust, you have to increase the dose. Which parameter, Vmax or Km, has more pronounced impact on CSS? Let's see. This in case of enzyme induction. How about enzyme inhibition? I think cimetidine, it reduces enzyme, inhibit enzyme. So that means Vmax goes down. So what is going to happen when Vmax goes down? CSS is going to increase. When CSS increase, we have to decrease the dose. This you have to remember. And then which parameter, Vmax and Km, has more pronounced impact on CSS of drugs? Showing on in a Vmax has more pronounced impact. If you go back to the note, and then explain non-competitive and competitive inhibition. How does Vmax and Km change in case of in case of competitive inhibition? In this case, let's see, competitive. Competitive in this case, Vmax won't change. Km goes down. Here just opposite. Vmax, if you go back here, you see here, Km does not change, Vmax decreases. So Km no change, Vmax goes down. So these are my important concepts I will discuss on Tuesday, and also I think tomorrow I will post second video for the assignment. But before that, I want you to watch this video.
I want to talk about competitive inhibitors and non-competitive inhibitors of enzymes and how they affect the Lineweaver-Burke plot. So let's begin by talking about the definitions of both competitive and non-competitive inhibitors individually and sort of what they do. So inhibitors, obviously they're going to inhibit the function of the enzyme. How? So if you think about competitive inhibitors, you think of the word compete, right? So competitive inhibitors, they compete with the substrate for binding at the active site, okay? So competitive inhibitors, they bind at the active site of an enzyme, okay? So in that sense, they're sort of competing, right, with the substrate, right? And I'm going to abbreviate substrate as S, and I'm going to abbreviate inhibitors as I. So they're competing for the substrate. So they're both trying to bind at the active site.
Okay, so this is the video you have to watch. If you are comfortable, you remember biochemistry, you don't know watch, but this is I recommend you watch. You remember that that link. You can just copy and paste and watch this. I think it is a 15-minute video. I hope, and this I guess only up to nonlinear kinetics you will have in quiz 2. Quiz 2, I don't think I will be able to complete that in other material, but all the material from quiz at the end of the quiz 2, I think, is multiple dosing to nonlinear kinetics. You will be in quiz 2, quiz 3. Anyway, I'm stumbling. I will send you an email what needs to be done regarding quiz 3. With this, I'm done. Okay, thank you.